Our first speaker recommends the ride down Highway 1 to Big Sur for all its spectacular views, or perhaps a visit to Point Lobos for its scenery and easy walking trails. He has been a meteorologist in the Air Force for 25 years, has spent 6 years as an environmental consultant, and is a certified consulting meteorologist. Today he will share some of his weather knowledge with us in his third speech, entitled, It's Just Bent Light. Please welcome Bill Gibbons.
Thank you, Madam Toastmaster. Judy Garland, in a song, sang, "There's a wonderful, magical place somewhere over the rainbow." Joni Mitchell sang that she had seen clouds from both sides now, but then it was cloud illusions that she recalled. America, in their song, A Horse with No Name, said that after 9 days, the desert had turned to sea. I'm sure that many of you have seen these meteorological phenomena in your daily lives, but what do they all have in common? You see, it's just bent light. Fellow Toastmasters and guests, I would like to just share today a little bit about how each of these meteorological phenomena are formed. First, the rainbow. Now, I don't know about you, but when I see one of these, I get an erratic feeling. White light from the sun interacts with a raindrop, and at that edge, the light refracts or bends. And many of you will remember from your physics days, we should all remember that, that refraction, the amount of refraction, is dependent upon wavelength, so that the red is refracted less than the indigo. Then within that light, the raindrop, the light reflects. There is a second refraction as the light exits the raindrop and begins to get that separation of colors. And this diagram explains very clearly why every time it rains, you don't get a rainbow. You have to get the sun and the raindrops at all of these angles all right at the right time to get the rainbow. And of course you need more than just one raindrop. You need a series of raindrops to get the kaleidoscope of colors that you see in the rainbow. One other thing that I should point out from this diagram. When you are looking at a rainbow, the sun is always at your back. And so, the next time you see a rainbow and somebody wants to know how is a rainbow formed, you just say, why, it's simply a refraction, a reflection, and a refraction, and a raindrop. You can remember all those numbers. How many of you have seen this halo? I know, Carl, I know that you have. This is actually known as a 22-degree halo. Now I want us all to think back to first grade. We have a piece of white construction paper and we're getting ready to cut out some snowflakes. Now what do you remember from cutting out snowflakes in first grade? They're supposed to be six-sided. Yes, indeed, ice crystals in clouds are six-sided, also known as hexagons. So ice crystals in clouds up high, six-sided. The light goes through those, and again, that light is bent or refracted at a 22-degree angle. And you will note that there is some color variation, just as in the rainbow, because the red, again, being refracted less than the indigo. So again, you have a whole series of ice crystals at various orientations in a cloud high up in the sky. The light refracts, and you get the 22-degree halo. So the next time you see one of these, and you want to really impress your friends, you can say that you can call it not just a halo, but the 22-degree halo. It is formed by a refraction in a hexagon. Now, I guess most of us have seen this scene driving down the highway in the summertime. I see people shaking their heads. You look into the distance, there's water on the highway. You even see the reflection of a car in front of you and some of the other objects in the distance. But lo and behold, you get up there, and it's all dry. There's no water. What is going on here? This is called an inferior mirage. It is also caused by refraction, but not of an object. What happens here is you have very warm air at the surface and cooler air above it. Light in the all cold air will go in a straight line directly to your eye. However, light rays that are further down in the cold air that are going toward the ground, because of this strong temperature difference, get bent and arrive at your eye. And so, the blue sky that should have hit the ground, that light actually gets refracted into your eye so that you see it's like a sea in the distance. So a mirage is merely my images refracted against the ground environment. So we can remember when we see the rainbow that it is a refraction, a reflection, and a refraction in a raindrop. The 22-degree halo is a refraction in a hexagon. And a mirage is merely my images refracted against the ground environment. But always remember, it's just bent light.